There are four variables that you need to talk about a gas's physical state. They are pressure, volume, amount, and temperature, or PV, N, and T. And scientists discovered a number of proportionalities relating these different variables. And we'll talk about a few of them. They discovered that volume of a gas and temperature of that gas are directly proportional, which is to say, as temperature increases, volume increases. They also discovered that volume is inversely proportional to pressure, which is to say, as the pressure goes up, the volume goes down. And they also discovered that volume of a gas is directly proportional to the amount of gas, to the number of moles of gas. So as you increase the amount of the gas, the volume goes up. And it's possible to combine all three of those proportionalities. Volume is directly proportional to moles and temperature, and it's inversely proportional to pressure. Now, this proportionality is great, but to make it more useful, we can add something known as a constant of proportionality. And we'll be using the symbol R for that constant. And this equality, this equation, is more commonly written as PV equals nRT. And this is the ideal gas equation, or sometimes the ideal gas law. And to use this equation, it's important that you remember that you must use an absolute temperature, which is to say the temperature value that you use in the equation has to be in Kelvin. For this equation to accurately describe gases, we need to imagine an idealized type of gas that obeys the following set of assumptions. Any gas that effectively follows these assumptions is something known as an ideal gas. And ideal gases very clearly don't exist in real life because both of those assumptions are clearly wrong. Gas particles are real things that will interact with one another with attractive and repulsive forces and collisions. And gas particles are real physical matter that take up real physical space, so you can't ignore their volume. That being said, most of the gases that you'll encounter behave ideally enough that you can use the equation and not be too far from the correct answer. Sometimes when you're using the ideal gas equation, you'll see reference to something called STP, which is the standard temperature and pressure for a gas. The standard temperature for a gas is 0 degrees Celsius, or 273.15 Kelvin. And the standard pressure for a gas is 1 atmosphere.